Over the last few videos, our idea of differentiation has stopping at function which show as y equal something of variable x, so say x squared, for example. So differentiating implicit function is when the function is not written at y is equal to some sort of x, but it is written at, say, differentiating x squared plus y squared. These are what called implicit function, in which the y is not attributed to any way of function of x. So how do we differentiate these functions? Let's just say now we see differentiating these functions as we call them d over dx. D over dx of x squared plus y squared is the differentiation of x squared plus y squared. Now this is equal to d dx. Again, this is an example that you can see how you can do all these exercises. You also do it the similar way. D over dx x squared plus d over dx y squared. Now this is d over dx x squared. This is obviously 2x plus now d over dy. So if we put dy here, what we need is to time it with dy over dx. So d over dy y squared times dy over dx. This time this is the same as d over dx. So here we have this is equal to 2x plus d over dy y squared. Now this gets us 2y times dy over dx. So this is actually the differentiation of d over dx x squared plus y squared, in which you put the y variable to one part and the x variable to one part, and then differentiate each of them. So here you differentiate y, there's usually the sign of dy over dx at the back. So let's say now in the exam they give you another type of function. So here they give you 2x squared plus y squared is equal to, say, 3xy. So this is a function they give you. And so let's say now you have to differentiate this. D over dx. You differentiate it on two sides. D over dx x squared plus y squared is equal to d over dx of 3xy. Now differentiating of 3xy, now you should treat this as the product rule, in which 3x is v, so v is equal to 3x and u is equal to y. So we have dv over dx is 3 and du over dy is so y differentiating of dy gets you so this du over dx is dy over dx, because when y differentiating with respect to dy you get 1, so that 1 times dy over dx. Right, so here is the differentiation of 3x and y. Now for the quotient rule, so you have d over dx is equal to u times dv over dx plus v times du over dx. This is the quotient rule. So here we have u is y times dv over dx is 3 plus v is 3x times du over dx, so that dy over dx. That is the differentiation of this. And so if we differentiate this, we have 2x plus 2y dy over dx is equal to 3y plus 3 dy over dx. Right, so here we have this equation. And so let's just say they ask if they want a stationary point of this function. The stationary point is one where dy over dx is 0. So for that, here we have 2x equal 3y. So the the function the stationary point is where the gradient is 0, which is when 2x is equal to 3y. So if you replace this into here, you can actually find x and y. So in this case, it can be 0 and 0, and it can also be another root, which you should try and find it by yourself. So that is the basic idea of how they can put implicit function in the exam. And there's just another idea I want to mention is that there's the second term derivative, which is denoted as d square y over dx square. And this is simply when you get dy over dx and you differentiating it again and getting this. So when this is bigger than 0, you're actually getting the minimum. And when this is smaller than 0, then you get the maximum. So when you differentiate this, let's say at this case we have dy over dx is, this is tricky because it's 3y minus 2x over 2y minus 3. So this is the dy over dx. So if you differentiate this again and get second derivative and try x and y, so here you can find x and y from here and here, and you try x and y there. So if it is bigger than 0, then you're actually getting the minimum value, and if it was smaller than 0, then you're actually getting the maximum value. So that's the basic idea of differentiating an implicit function.